welcome to the video. In this scenario, we're told that a person has had a constant 28 CDs. So think about that key word in mathematics. Constant means unchanging since 2000. So I guess for Christmas in 2000, the person was given 28 CDs and they've never gotten another one and they've never lost one. And we have two variables defined here in this story: n, the number of CDs the person has, and t, the number of years since 2000. And they're asking us to find an equation that models the number of CDs owned by the person, and then to graph that equation. So if we're thinking about finding an equation, we could set up a table with our independent and dependent variables. So remember, t, the year since 2000, is generally going to be our independent variable, and if we're unsure here, we can always ask the question, well, does knowing how many CDs I have tell me what year it is? No. But does knowing the year tell me how many CDs I have? Yeah. The year is going to go on changing no matter how many CDs I have, so the t, the year, is the independent variable, and n, the number of CDs we have, is dependent. And so let's think about, we can always fill in our table with some first values. The value of 0 is representing the year 2000. How many CDs did that person have in the year 2000? They had 28 CDs. If we try t equals 1, and you could fill in just kind of get a trend there. In 2001, they still had 28 CDs. 2002, they still had 28. In 2003, still 28. So we're starting to get the feeling that it doesn't matter what we plug in for t, our n will always be 28. And that's true. In fact, even when t is some random variable t, n is going to be 28. So when we think about writing an equation here, n equals what? As I look at all those n's, t doesn't show up anywhere. We could just say n is equal to 28. Now to plot the graph of that equation, they've given us some points to start with. So they want us to plot first the point t equals 0. So we can think about, here's that ordered pair already set up. It's going to be 0, comma, 28. And here's the other points we're going to need: 1, comma, 28, and 3, comma, 28. When you go to do your graph, if you're doing it in WAMAP, it's a computerized setup. If you're doing it by hand, take the time to make sure 0 is on your graph, even though it's not going to show up in WAMAP. In general, we always, always, always want to begin graphs at the origin with 0 on the x and 0 at the y. WAMAP is going to start with like 25 or 26 or something else depending on your value. So if you wanted to adapt their graph, one thing you can do, although it's not a great idea, it can cause problems, but if that's the situation you're in, is to draw a little jagged line between 0 and 25 to say, okay, I'm skipping a lot of values here between 0 and 25. That jagged line tells us that, and then from 25 we're going to count by ones up. Also want to label your axes. So my independent variable t is on the horizontal axis, my dependent variable n is on the vertical axis, and now we can label in that value 0, 28. So here's my x is 0 right here, and then we go up to 28 on the y-axis, or the n-axis. Next I have 1, comma, 28 right there. And then my other point that I had was 3, comma, 28, and you can see that pattern showing up. They're all going to fall in a straight line, so when we connect them, we're getting a straight line like that, indicating that the value of the CDs has been 28 since our base year, going on forever. To make a really good graph, you also want to make sure you're always labeling both axes. So for our n-axis, n represents number of CDs, so we'd want to make sure to fill that in if you're doing this on your paper, number of CDs. And on your vertical axis, I'm kind of out of room, so I'll write it above, but on your paper, write it below, and we'll say this is the year since 2000. It's all, you always want to